Hello dear students, welcome to the lecture 2 of software engineering course. Today's topic is software processes. Part 1, let's start. The topics covered today are
Software process models. Process activities. Coping with change. The rational unified process. The RUP is a prescriptive, well-defined system development process, often used to develop systems based on object and/or component-based technologies. It is based on sound software engineering principles such as taking an iterative, requirements-driven, and architecture-centric approach to software development, an example of a modern software process.
the software process.
A structured set of activities required to develop a software system. Many different software processes but all involve specification, defining what the system should do, design and implementation, defining the organization of the system and implementing the system, validation, checking that it does what the customer wants, evolution, changing the system in response to changing customer needs.
So the software processes involves all of these four main attributes.
A software process model is an abstract representation of a process. It presents a description of a process from some particular perspective. Software process descriptions. When we describe and discuss processes, we usually talk about the activities in these processes, such as specifying a data model, designing a user interface, etc., and the ordering of these activities. Process descriptions may also include products, which are the outcomes of a process activity; roles, which reflect the responsibilities of the people involved in the process; pre- and post conditions, which are statements that are true before and after a process activity has been enacted or a product produced. Plan-driven and agile processes. Plan-driven processes are processes where all of the process activities are planned in advance and progress is measured against this plan. In agile processes, planning is incremental and it is easier to change the process to reflect changing customer requirements. In practice, most practical processes include elements of both plan-driven and agile approaches. There are no right or wrong software processes.
So you can either follow plan-driven processes or agile processes. It is up to you, based on what you need to achieve, what you need to program or code or construct.
Software process models.
Okay, so there are several process models.
The Waterfall model. Plan-driven model. Separate and distinct phases of specification and development. Incremental development. Specification, development and validation are interleaved. May be plan-driven or agile. Reuse-oriented software engineering. The system is assembled from existing components. May be plan-driven or agile. In practice, most large systems are developed using a process that incorporates elements from all of these models.
Okay, so let's check out the waterfall model. Requirements definition. system and software design, implementation and unit testing, integration and system testing, operation and maintenance. You see, it's a very planet model and each one can feedback the previous stages, and therefore the changes may be made according to these feedback. Okay.
Waterfall model phases.
There are separate identified phases in the waterfall model.
There are separate identified phases in the waterfall model. Requirements analysis and definition, system and software design, implementation and unit testing, integration and system testing, operation and maintenance.
So let's read one by one.
Requirements analysis and definition. System and software design. Implementation and unit testing. Integration and system testing. Operation and maintenance. The main drawback of the waterfall model is the difficulty of accommodating change after the process is underway. In principle, a phase has to be complete before moving on to the next phase.
So it is not very agile for waterfall model because you plan and design everything before starting to constructing your software, and there are some more problems.
Waterfall model problems. Inflexible partitioning of the project into distinct stages makes it difficult to respond to changing customer requirements. Therefore, this model is only appropriate when the requirements are well understood and changes will be fairly limited during the design process. Few business systems have stable requirements. The waterfall model is mostly used for large systems engineering projects where a system is developed at several sites. In those circumstances, the plan-driven nature of the waterfall model helps coordinate the work.
What can we give an example for such project? Perhaps a project of NASA may be like this because they are huge projects, huge number of engineers working on such projects, they have huge budgets, so everything can be planned and designed before even starting the project, and they may be separated to several sites. Uh, so maybe I don't know how they are working, but a project of NASA may be like that. For example, a mission to Mars may be like this.
Incremental development.
Outline description. You just first outline a description and then you start developing and incrementally improve your development. Concurrent activities, they are happening at the same time: specification, development, and validation. So these three feedback each other continuously, and then uh, as you get close to be done, you can publish initial version, you can publish intermediate versions, and finally, after the validation, you can publish the final version. You see, these two are also feedback having these, and this is the final version. Okay.
Incremental development benefits. The cost of accommodating changing customer requirements is reduced. The amount of analysis and documentation that has to be redone is much less than is required with the waterfall model. It is easier to get customer feedback on the development work that has been done. Customers can comment on demonstrations of the software and see how much has been implemented.
For example, can you have this in NASA project? No, because you can't even test the device. Let's say you are coding the software of the air spacecraft navigation system, and it can be only tested when it is actually going to the Mars. You can test it on the Earth. Of course, they are probably developing uh, artificial artificial simulation platforms and simulations. However, the real test and the real feedback can only be get when the space aircraft is on its way to the Mars. So you see the difference of incremental development and the waterfall development. Okay.
More rapid delivery and deployment of useful software to the customer is possible. Customers are able to use and gain value from the software earlier than is possible with a waterfall process.
For example, you can apply this to an e-commerce website. You can publish initial version, the customers start using it, and as the customers see the missing parts, they can feedback you and you can improve them. However, you cannot use this strategy in health critical systems. For example, let's say you are purchasing an MR device and MIR device, and you can't just use it on a you can't just use unfinished health critical system on humans, because it may kill humans, it may badly hurt humans. So you see, for each type of job you can use different types of software development. You can publish an initial version, an unfinished version of a game, because it wouldn't hurt anyone in case of errors or bugs or problems. Okay. There are many startup projects which uses agile development, incremental development. They publish the first as beta, and then they start generating some money and they continue developing the games.
Incremental development problems. The process is not visible. Managers need regular deliverables to measure progress. If systems are developed quickly, it is not cost-effective to produce documents that reflect every version of the system. System structure tends to degrade as new increments are added. Unless time and money is spent on refactoring to improve the software, regular change tends to corrupt its structure. Incorporating further software changes becomes increasingly difficult and costly.
Yes, this is so true, because as you plan and design in the development phase, you may make some huge changes to your structure, and as you make changes to your initial structure, it corrupts its structures. This is so true. Negative side of the incremental development.
Reuse-oriented software engineering. Based on systematic reuse where systems are integrated from existing components or COTS, commercial off-the-shelf systems. Process stages: component analysis, requirements modification, system design with reuse, development and integration. Reuse is now the standard approach for building many types of business system.
This is true because you shouldn't try to invent the wheel again and again. You should use as much as possible what is already there, what is already done, and what is already checked and verified. Open software libraries and frameworks are great source of tools to use in your projects.
Reuse-oriented software engineering.
Requirement specification, component analysis, requirements modification, system design with reuse, development and integration, system validation.
Types of software component. Web services that are developed according to service standards and which are available for remote invocation. Collections of objects that are developed as a package to be integrated with a component framework such as .NET or J2EE. Standalone software systems (COTS) that are configured for use in a particular environment.
The process activities.
Real software processes are interleaved sequences of technical, collaborative and managerial activities with the overall goal of specifying, designing, implementing and testing a software system. The four basic process activities of specification, development, validation and evolution are organized differently in different development processes. In the waterfall model, they are organized in sequence, whereas in incremental development they are interleaved.
Okay, software specification.
The process of establishing what services are required and the constraints on the system's operation and development.
Okay, requirements engineering process.
Feasibility study. Is it technically and financially feasible to build the system?
This is so important. You shouldn't try to build systems that are unfeasible. They're not just possible or financially and economically they are impossible to achieve.
Requirements elicitation and analysis. What do the system stakeholders require or expect from the system?
Requirements specification, defining the requirements in detail. Requirements validation, checking the validity of the requirements. So, you see, this is named as requirements engineering process. You are not just a coder. You are not just a programmer. If you want to be a software engineer, you need to have an idea, have a plan, and have habits of an engineer. For example, just for requirements, you need to do every necessity check like this one. Feasibility study, requirements elicitation and analysis, requirements specification, requirements validation, and such. Okay. This will separate you from the regular coders, programmers, freelancers. Okay, as a software engineer.
The requirements engineering process.
Okay, feasibility study. From feasibility study, you generate feasibility report. Requirements elicitation and analysis. Based on that, you start requirement specification and system models. From requirement specification, you can feedback requirements elicitation analysis. You can move to the next stage, user and system requirements. And from system models and user and system requirements, you can compose requirements documents. And from requirements specification, you can do requirements validation. And based on that feedback, you can modify requirements specification and requirement elicitation analysis. You see, these ones have feedback from the further process, and after all done, you compose the requirements document.
Software design and implementation. The process of converting the system specification into an executable system.
Software design.
Design a software structure that realizes the specification.
Implementation.
Translate this structure into an executable program. The activities of design and implementation are closely related and may be interleaved.
So after you have done the requirements engineering process, you move to the software design and implementation process. In this one, there are there are software design, implementation, and uh, you uh, you uh, you execute the both processes at the same time in many cases. Okay, interleaved. A general model of the software design process. There are design inputs, which are platform information, requirement specification, data description, and there are design activities, architectural design, interface design, component design, and they both connect to the database design. And there is design outputs, system architectures, database specification, interface specification, component specification. Okay, so design activities. Let's read them carefully.
Architectural design, where you identify the overall structure of the system, the principal components, sometimes called subsystems or modules, their relationships and how they are distributed. Interface design, where you define the interfaces between system components. Component design, where you take each system component and design how it will operate. Database design, where you design the system data structures and how these are to be represented in a database.
So you see, design has many different subsections, and you need to follow this code of practice to be a good software engineer. And there is software validation.
Verification and validation (V&V) is intended to show that a system conforms to its specification and meets the requirements of the system customer. Involves checking and review processes and system testing. System testing involves executing the system with test cases that are derived from the specification of the real data to be processed by the system. Testing is the most commonly used V&V activity.
For testing, there are usually the companies and engineers uh, programs another code, another software. So there are being a test software which provides inputs and expects some output. So whenever you make changes to your main software, you retest your main software with these testing procedures and see if there are any errors, if an unexpected error happened or not. Stages of testing: component testing, system testing, acceptance testing. So you see, if acceptance is not achieved, you go back to the component testing and system testing and acceptance testing again. Okay, testing stages.
Development or component testing. Individual components are tested independently. Components may be functions or objects or coherent groupings of these entities.
System testing.
Testing of the system as a whole. Testing of emergent properties is particularly important.
Okay, acceptance testing.
Testing with customer data to check that the system meets the customer's need.
Because testing phase is in a plan-driven software process. You see, it is getting expanded. Requirement specification, system design, detailed design, model and unit code and test. There is acceptance test plan, system integration test plan, subsystem integration test plan. There is subsystem integration test, system integration test, acceptance test, and service. However, if you follow this plan-driven software process, you can much easily achieve. You can much easily code very large software systems. Okay, software evaluation.
software is inherently flexible and can change. As requirements change through changing business circumstances, the software that supports the business must also evolve and change. Although there has been a demarcation between development and evolution, maintenance, this is increasingly irrelevant as fewer and fewer systems are completely new.
Okay, system evaluation. So define system requirements, assess existing systems here, propose system changes, modify systems, compose new system, and from there you check whether you assess again the existing. Okay, so key points of the part 1 of software processes here. Which are the key points? Let's read one by one.
Software processes are the activities involved in producing a software system. Software process models are abstract representations of these processes. General process models describe the organization of software processes. Examples of these general models include the Waterfall model, incremental development, and reuse-oriented development.
More key points.
Requirements engineering is the process of developing a software specification. Design and implementation processes are concerned with transforming a requirements specification into an executable software system. Software validation is the process of checking that the system conforms to its specification and that it meets the real needs of the users of the system. Software evolution takes place when you change existing software systems to meet new requirements. The software must evolve to remain useful.
So if you don't make any updates to your existing software, eventually it will become obsolete and left by the customers and clients. Okay. So lecture 2, software processes part 2, coping with the change. Okay, coping with change. All right.
Change is inevitable in all large software projects. Business changes lead to new and changed system requirements. New technologies open up new possibilities for improving implementations. Changing platforms require application changes. Change leads to rework, so the costs of change include both rework, e.g., reanalyzing requirements, as well as the costs of implementing new functionality. Reducing the costs of rework. Change avoidance, where the software process includes activities that can anticipate possible changes before significant rework is required. For example, a prototype system may be developed to show some key features of the system to customers. Change tolerance, where the process is designed so that changes can be accommodated at relatively low cost. This normally involves some form of incremental development. Proposed changes may be implemented in increments that have not yet been developed. If this is impossible, then only a single increment, a small part of the system, may have been altered to incorporate the change. Software prototyping. A prototype is an initial version of a system used to demonstrate concepts and try out design options. A prototype can be used in the requirements engineering process to help with requirements elicitation and validation, in design processes to explore options and develop a UI design, in the testing process to run back-to-back tests. Benefits of prototyping. Improved system usability. A closer match to users' real needs. Improved design quality. Improved maintainability. Reduced development effort.
Okay, the process of prototype development. Establish prototype objectives, prototyping plan. Define prototype functionality, outline definition, develop prototype, executable prototype, evaluate prototype, evaluation report. Prototype development.
May be based on rapid prototyping languages or tools. May involve leaving out functionality. Prototype should focus on areas of the product that are not well understood. Error checking and recovery may not be included in the prototype. Focus on functional rather than non-functional requirements such as reliability and security. Throw away prototypes. Prototypes should be discarded after development as they are not a good basis for a production system. It may be impossible to tune the system to meet non-functional requirements. Prototypes are normally undocumented. The prototype structure is usually degraded through rapid change. The prototype probably will not meet normal organizational quality standards. Incremental delivery. Rather than deliver the system as a single delivery, the development and delivery is broken down into increments with each increment delivering part of the required functionality. User requirements are prioritized and the highest priority requirements are included in early increments. Once the development of an increment is started, the requirements are frozen, though requirements for later increments can continue to evolve. Incremental development and delivery. Incremental development. Develop the system in increments and evaluate each increment before proceeding to the development of the next increment. Normal approach used in agile methods. Evaluation done by user, customer proxy. Incremental delivery. Deploy an increment for use by end users. More realistic evaluation about practical use of software. Difficult to implement for replacement systems as increments have less functionality than the system being replaced.
So if you are going to replace a whole working system, incremental delivery may not be appropriate for it, because with incremental delivery, you are adding functionality of the system by one by. However, if you are replacing an existing system, a working system, it may cause serious problems of the working system. It may cause damage of profit and other issues. So incremental delivery and incremental developments may not suit very well to every kind of application. In software engineering, the methods you choose have to be appropriate to the software you are developing. Okay, incremental delivery. Define outline requirements. Assign requirements to increments. Design system architecture. Develop system increment. Update increment. Integrate increment. Validate system. Deploy increment. If system incomplete, continue develop system increment. If if system is incomplete, develop system increment. If system is complete, final system.
Incremental delivery advantages. Customer value can be delivered with each increment, so system functionality is available earlier. Early increments act as a prototype to help elicit requirements for later increments. Lower risk of overall project failure. The highest priority system services tend to receive the most testing.
So what problems there are?
Incremental delivery problems. Most systems require a set of basic facilities that are used by different parts of the system. As requirements are not defined in detail until an increment is to be implemented, it can be hard to identify common facilities that are needed by all increments. The essence of iterative processes is that the specification is developed in conjunction with the software. However, this conflicts with the procurement model of many organizations, where the complete system specification is part of the system development contract.
Okay, another model.
Boehm's spiral model. Process is represented as a spiral rather than as a sequence of activities with backtracking. Each loop in the spiral represents a phase in the process. No fixed phases such as specification or design. Loops in the spiral are chosen depending on what is required. Risks are explicitly assessed and resolved throughout the process. Boehm's spiral model of the software process.
Okay, so where does it start? It starts from here, however, it is a spiral service and acceptance test, integration test, develop, verify, next level product, unit test, code, detailed design, operational prototype. You see, in spiral model, there is no fixed phases. Okay, there are loops in the spiral chosen depending on what is required. So when you are first starting, what would be the requirement? Okay, what would be the required? Probably it would be development plan or determine objects, alternatives and constraints. Okay, so you choose what is next as a requirement, you do that, and choose what is next as a requirement, you do that, and continue choosing what is next depending on what is required. Okay, this is the spiral model. Let's see one by one.
Spiral model sectors. Objective setting. Specific objectives for the phase are identified.
Okay, objective setting. So it is this one. Determine objectives, alternatives, and constraints. Okay.
Risk assessment and reduction. Risks are assessed and activities put in place to reduce the key risks.
So you see, evaluate alternatives, identify, resolve risk, risk analysis, and risk analysis. Each time we do evaluate alternatives, identify, and resolve risks.
Development and validation. A development model for the system is chosen, which can be any of the generic models.
So it can be any of the development models. Okay.
Planning. The project is reviewed and the next phase of the spiral is planned.
All right.
Spiral model usage. Spiral model has been very influential in helping people think about iteration in software processes and introducing the risk-driven approach to development.
So this is a risk-driven approach. Based on the risk and evaluation, you pick the next phase.
In practice, however, the model is rarely used as published for practical software development.
So in practice, it is not very practical as it is on the paper. 1 second. Okay. The rational unified process.
A modern generic process derived from the work on the UML and associated process. Brings together aspects of the three generic process models discussed previously. Normally described from three perspectives. A dynamic perspective that shows phases over time, a static perspective that shows process activities, a proactive perspective that suggests good practice.
So, uh,
Phases in the rational unified process.
there is inception phase, elaboration phase, construction phase, and transition phase. This is phase iteration. Okay, so rational unified phases, inception,
Establish the business case for the system.
elaboration,
Develop an understanding of the problem domain and the system architecture.
construction,
System design, programming and testing.
transition,
Deploy the system in its operating environment.
so we continue.
RUP iteration.
In phase iteration,
Each phase is iterative with results developed incrementally.
cross phase iteration,
As shown by the loop in the RUP model, the whole set of phases may be enacted incrementally.
okay,
Static workflows in the rational unified process.
so workflow,
Business modeling.
the description of workflow,
The business processes are modeled using business use cases.
requirements,
Actors who interact with the system are identified and use cases are developed to model the system requirements.
analysis and design,
A design model is created and documented using architectural models, component models, object models, and sequence models.
implementation,
The components in the system are implemented and structured into implementation subsystems. Automatic code generation from design models helps accelerate this process.
okay, we continue to
Static workflows in the rational unified process.
okay, testing,
Testing is an iterative process that is carried out in conjunction with implementation. System testing follows the completion of the implementation.
so there is deployment,
A product release is created, distributed to users and installed in their workplace.
configuration and change management,
This supporting workflow managed changes to the system.
there is project management,
This supporting workflow manages the system development.
there is environment,
This workflow is concerned with making appropriate software tools available to the software development team.
okay, so
RUP good practice.
develop software iteratively,
Plan increments based on customer priorities and deliver highest priority increments first.
this may be very useful depending on your situation. Let's say you are building an e-commerce website, and what would be the highest priority? A working chart system, a working payment system. You can deliver them at the first, and then you can make cosmetic changes or functionality increments based on what is highest priority. You can develop the software that way. Manage requirements.
Explicitly document customer requirements and keep track of changes to these requirements. Use component-based architectures. Organize the system architecture as a set of reusable components. RUP good practice.
So this is a good practice of RUP development. Okay, you should follow this.
Visually model software. Use graphical UML models to present static and dynamic views of the software. Verify software quality. Ensure that the software meets organizational quality standards. Control changes to software. Manage software changes using a change management system and configuration management tools.
Okay, so the key points of part 2 of the lecture 2.
Processes should include activities to cope with change. This may involve a prototyping phase that helps avoid poor decisions on requirements and design.
So your software has to be designed, planned in a way that it could be able to cope with the changes, cope with the new requirements, cope with the new trends, and such things. It shouldn't be static, it shouldn't be non-changing. You should be designed in a way that you could improve its features and add new features to it so you can cope with the changes.
Processes may be structured for iterative development and delivery so that changes may be made without disrupting the system as a whole.
This is also very important because let's say your customer requested you to develop a very big system. The development will take this system, let's say, will take approximately 5 years to develop, but for 5 years your customer cannot go without making any money, right? So you can plan that your processes may be structured for iterative development and delivery, so your customers start putting your software on the usage and start making money and can pay you money, uh, let's say monthly. Meanwhile, he's also making money off the software. So in the end, your customer still gets its software and you get paid every month, and the customer also generates some money. This is most of the systems, how the most of the systems are done in today. If they are, if your customer is not very big and can throw away some money until and wait several years until making money from that investment.
The rational unified process is a modern generic process model that is organized into phases: inception, elaboration, construction and transition, but separates activities, requirements, analysis and design, etc. from these phases.
So this is a modern generic process, and probably it is being used commonly. Let's check it out from the internet. Okay, let's read about it from the Wikipedia.
The Rational Unified Process (RUP) is an iterative software development process framework created by the Rational Software Corporation, a division of IBM since 2003. 1. RUP is not a single concrete prescriptive process, but rather an adaptable process framework, intended to be tailored by the development organizations and software project teams that will select the elements of the process that are appropriate for their needs. RUP is a specific implementation of the unified process.
Okay, there is some history. Okay, let's read about some building blocks.
RUP is based on a set of building blocks and content elements, describing what is to be produced, the necessary skills required, and the step-by-step explanation describing how specific development goals are to be achieved. The main building blocks, or content elements, are the following. Roles. Who? A role defines a set of related skills, competencies and responsibilities. Work products. What? A work product represents something resulting from a task, including all the documents and models produced while working through the process. Tasks. How? A task describes a unit of work assigned to a role that provides a meaningful result. Within each iteration, the tasks are categorized into 9 disciplines. 6. Engineering disciplines: business modeling, requirements analysis and design, implementation, test, deployment. 3. Supporting disciplines: configuration and change management, project management, environment. 4. Project life cycle phases. The RUP has determined a project life cycle consisting of 4 phases. These phases allow the process to be presented at a high level in a similar way to how a waterfall-styled project might be presented, although in essence the key to the process lies in the iterations of development that lie within all of the phases. Also, each phase has one key objective and milestone at the end that denotes the objective being accomplished. The visualization of RUP phases and disciplines over time is referred to as the RUP hump chart.
And let's zoom in a bit. Inception phase.
The primary objective is to scope the system adequately as a basis for validating initial costing and budgets. In this phase, the business case, which includes business context, success factors, expected revenue, market recognition, etc., and financial forecast, is established. To complement the business case, a basic use case model, project plan, initial risk assessment and project description, the core project requirements, constraints and key features are generated. After these are completed, the project is checked against the following criteria. Stakeholder concurrence on scope definition and cost schedule estimates. Requirements understanding as evidenced by the fidelity of the primary use cases. Credibility of the cost schedule estimates, priorities, risks, and development process. Depth and breadth of any architectural prototype that was developed. Establishing a baseline by which to compare actual expenditures versus planned expenditures. If the project does not pass this milestone, called the life cycle objective milestone, it either can be cancelled or repeated after being redesigned to better meet the criteria.
Okay, and the second phase is
elaboration phase. The primary objective is to mitigate the key risk items identified by analysis up to the end of this phase. The elaboration phase is where the project starts to take shape. In this phase, the problem domain analysis is made and the architecture of the project gets its basic form. The outcome of the elaboration phase is a use case model in which the use cases and the actors have been identified and most of the use case descriptions are developed. The use case model should be 80% complete. A description of the software architecture in a software system development process. An executable architecture that realizes architecturally significant use cases. Business case and risk list which are revised. A development plan for the overall project. Prototypes that demonstrably mitigate each identified technical risk. A preliminary user manual optional. This phase must pass the life cycle architecture milestone criteria answering the following questions. Is the vision of the product stable? Is the architecture stable? Does the executable demonstration indicate that major risk elements are addressed and resolved? Is the construction phase plan sufficiently detailed and accurate? Do all stakeholders agree that the current vision can be achieved using current plan in the context of the current architecture? Is the actual versus planned resource expenditure acceptable? If the project cannot pass this milestone, there is still time for it to be cancelled or redesigned. However, after leaving this phase, the project transitions into a high-risk operation where changes are much more difficult and detrimental when made. The key domain analysis for the elaboration is the system architecture. Construction phase. The primary objective is to build the software system. In this phase, the main focus is on the development of components and other features of the system. This is the phase when the bulk of the coding takes place. In larger projects, several construction iterations may be developed in an effort to divide the use cases into manageable segments, produce demonstrable prototypes.
So you see that until the coding starts, there are many prior things to be completed. You first complete the inception phase, and then you need to complete the elaboration phase. You make all the plan, and you make all the documentation, you make the risk analysis, etc. And after that, after only establishing all these prior phases, you start coding. This is how software engineer behaves. The software engineer does not immediately start coding and then try to make all the changes of meanwhile coding and developing. That would be detrimental to the system architecture and other things. That would reduce the quality of your software. It may be impossible to continue after a certain phase, and you may need to recode everything and such things. So a software engineer behaves with planning and with design, and then after doing and completing the initial phases, a software engineer moves to the coding. So you see, after everything is planned, it seems like the coding is the easiest part, right?
Transition phase. The primary objective is to transit the system from development into production, making it available to and understood by the end user. The activities of this phase include training the end users and maintainers and beta testing the system to validate it against the end user's expectations. The system also goes through an evaluation phase. Any developer which is not producing the required work is replaced or removed. The product is also checked against the quality levels set in the inception phase. If all objectives are met, the product release milestone is reached and the development cycle is finished. Six best software engineering practices are defined for software projects to minimize faults and increase productivity. These are: develop iteratively. It is best to know all requirements in advance. However, often this is not the case. Several software development processes exist that deal with providing solutions to minimize cost in terms of development phases. Manage requirements. Always keep in mind the requirements set by users. Use components. Breaking down an advanced project is not only suggested but in fact unavoidable. This promotes ability to test individual components before they are integrated into a larger system. Also, code reuse is a big plus and can be accomplished more easily through the use of object-oriented programming. Model. Visually use diagrams to represent all major components, users, and their interaction. UML, short for Unified Modeling Language, is one tool that can be used to make this task more feasible. Verify quality. Always make testing a major part of the project at any point of time. Testing becomes heavier as the project progresses but should be a constant factor in any software product creation. Control changes. Many projects are created by many teams, sometimes in various locations, different platforms may be used, etc. As a result, it is essential to make sure that changes made to a system are synchronized and verified constantly. See continuous integration. In software engineering, continuous integration (C) is the practice of merging all developers' working copies to a shared mainline several times a day. 1. Grady Booch first proposed the term C in his 1991 method. 2. Although he did not advocate integrating several times a day. Extreme Programming (XP) adopted the concept of C and did advocate integrating more than once per day, perhaps as many as tens of times per day.
Okay, so if there is anything that you cannot understand fully, you can look to the internet for more information. There is always more information. Being a software engineer will only increase your value, will only increase your chances to get a good job offer, a good payment, and will separate you from the coders and developers. Okay, there are much more coders and developers today than the 10 years ago or 20 years ago. There is a very high competition. So to separate yourself from programmers, coders, freelancers, you need to become a good software engineer so that big corporations can see the value in you, such as Google, Facebook, Apple, Amazon, and such companies, and they will likely to hire you because being a software engineer will give you ability to work as a team, as a part of a team, as a part of a big corporation. All right. So this is for today's lecture. Let me push the lecture slide to our GitHub repository. The software engineer, you should learn. Actually, you have to learn how to use a code management system such as GitHub. Okay. So this must be one of your priorities to be able to use a code management system. I will give you a project in this semester for this course, and you will be forced to use a code management system such as GitHub or Bitbucket or such. Okay, with any code management software such as Git Bash. Which one? This is Git Bash which I am using. So the origin master is the name of my branch. Okay, there can be branches. Let's see. Okay, it's updated now. When I click it, I see the lecture slides, lecture 2 slides uploaded. You see them here. And I have updated the first slides as well. Okay, hopefully see you next week. Stay safe from coronavirus. Okay, see you.